Greetings, Professor McKee here with another quick Excel tip your finance professor wishes you knew. In this video, we will learn how to use the NPER function in Excel to find the maturity for an annuity due. In any intro finance class, you will have a unit on annuities, and we professors will always have questions where we give you 4 of the annuity's characteristics and ask you to find that missing one. If you want to ace those questions, this video is for you. I have prepared a standard question right here, asking us to find the number of years it's going to take to accumulate to a particular future value. Effectively, how many periods in this annuity do we need to reach the given future value? And this is an annuity due. We know that because payments happen at the beginning of each period. That is the only difference. If you see beginning of each period inside an annuity question, you know you have annuity due. If you see end of each period or end of each year, that's when it's a normal, ordinary annuity. Now, for any annuities, it's best to convert this verbal description here into actual numbers that we can use to calculate our value. So for annuity due, since we know it is true that it's an annuity due, I'm going to put a 1. We'll get to why I need to do that in just a little bit. N is our number of periods we're trying to find, so we skip that. And interest rate is 5%. So 0.05 for I. Present value, we are not given a value. In that case, we assume it's 0. It's pretty common for an annuity question like this to have the account start with nothing. Payment, that is the amount of money we put in each year, each period. That's that 6,000. And future value, that's the amount we want to accumulate, and that's the big $1 million that I'm trying to accumulate in this savings account. So 1 million. Now, one last thing, I need to make an adjustment with present value, payment, and future value. Excel's function assumes that cash flows are either going in or out, and that they're going to be some going in and some coming out. And so if you don't do this, either Excel will have an error message, in which case that's actually a good thing, because then you know something's wrong and you have to go back and fix it. Or if you have potentially a problem where you put cash flows in, the signs are wrong, you get an actual number and you don't realize there's a problem, you use that as your answer and get the wrong answer. So I'm going to treat this as, say cash is going into the account, that's the 6,000 per year that we put in, and the 1 million, presumably after we get 1 million, we're going to do something with it. We're going to take it out of the account, spend it on stuff, and so that's going to be going away from the account. So the 6,000 and 1 million are going in opposite directions. From my perspective, I'm putting this money into the account. That's cash that I no longer have access to. I'm going to treat that as a negative cash flow, and then the 1 million, once I gain access to it, is positive for me, so that's going to be a positive cash flow. Now we go up to B6. We type in equals NPER, stands for number of periods, and Excel tells us what values we need to enter. First one is rate, that's going to be 0.05. Payment is negative 6,000. Present value is 0. Our future value is in brackets because we have a default value. The default value is 0. We are trying to accumulate 1 million, not 0 million. So we put in 1 million. And then the last one is type. That's also in brackets because there's a default value. By default, Excel will have type be 0. And if type is 0, Excel will treat our annuity as an ordinary annuity with payments at the end of the year. We don't want this. We want payments at the beginning of each year. And the way we tell Excel, hey, treat this as a beginning of the year annuity, is by putting in 1 for type. So I put in 1. That's the same reason I put in 1 for B5. Close parentheses, and we get our function right here. We have a value of 44, so 44 years, rounded up, it's 45 years to accumulate that $1 million. As long as I start when I'm young, I can actually do this. Now, if we want to use better Excel practices, be a little fancier, and most importantly, be able to reuse this for future annuity questions, since there's probably going to be more than one that we are needing to solve, instead of directly entering all the values, I can use cell references and put the correct values in the cells that I am referencing inside this function. So inside this function, the first thing I need is rate. I entered my rate in B7 right here. So I type in B7, and now Excel will take whatever interest rate I put in for B7 as the interest rate for the function. Payment was in B9. Present value was B8. Future value was B10. And then type, I put type up here in B5, and I put in the 1 because I knew that I would need to have a 1 to make it be payment at the beginning of the period. So B5. Enter, and I get that same exact 44.88. But now I can change any of these values, or the annuity 2 value, and this function will automatically update. This is good in case I have a new annuity question. I need to update things. Also, it's nice because if I have a big number like this 1 million, when I was entering directly, I had to just count out the number of zeros. Here I can see, oh yes, I have the right number of zeros, there's commas, there's periods, delimiting things. It's a lot easier to tell that I have the right number for my future value. Not so important if it's a small number like 5 or 6,000, but a big thing like 1 million can cause issues because you have to count out the zeros. It's easy to miscount, and anything that reduces errors like this is generally a good thing. Now to demonstrate, let's try changing something here. So let's assume that we don't have an annuity 2. It's actually an ordinary annuity. I would just change this to 0. And as you can see, my number is updated. It's now 45.7. It's gone up by a little bit. Not surprising. Shouldn't be surprising anyways, because if we pay at the beginning of the year, that's an extra year every payment has to accumulate. If I pay at the end of the year, which would be an ordinary annuity, I have one less year, so I need more time to reach that same 1 million, and that more time is, roughly speaking, an extra year. So with this single function, you can now find the maturity for any annuity, whether it's a due or an ordinary annuity, for your finance class that your professor might throw at you. If you found this video helpful, please comment, like, and/or subscribe so that other students can find this video too. Happy studying.